Yeah, welcome to our session. We realized it has a quite long and maybe academic names. Keys to successfully monitoring and optimizing innovative and sophisticated cloud applications. We have to admit we can't remember the name ourselves most of the time. So what this session is about in one sentence, how can you really monitor highly advanced applications you're building with leading edge technology? So this is what it's about. If you came here for something else, feel free to leave. Otherwise, you will have a very nice session. Some words about us here. I'm Alice Reitbauer. I'm the lead of the Dynatrace Innovation Lab, where we build new technologies based on different stacks and mostly deal how we can monitor, optimize, and tune these technologies. And with me is?
I'm Daniel Kahn. I'm technical product manager of Dynatrace, and I'm partly responsible for these things we are trying to show today. So if something does not work, it's mostly my fault.
Unless it's the demo, then it's actually my fault.
Unless it's the demo or the Wi-Fi.
Okay, so let's get started. To get started, I'd like to share a little story with you. So you might wonder sometimes when people do demos and when they prepare sessions, so how do they come up with those ideas for those sessions? Do they sit in an office and think the entire day and suddenly there's this epiphany, okay, we have to do a demo or a session about something? Or do they get together, some alcohol is involved, and then suddenly they have an idea what to do in the session? Well, the second thing actually happens in reality, but this session was different. This really goes back to the last holiday season, where I started to build my first bigger Alexa skill for my home, because I really had to solve a problem that I was facing every day. So when I go to work in the morning, I realize I always put on my shoes first, forget that I opened the garage door, and then realize that I have to get back into my kitchen where the home automation system is to open up the garage door. There's a very nice hardwood floor in there, and my girlfriend totally doesn't like me to wear my sneakers walking on this nice hardwood floor. So there's two solutions to this problem. I could just have gotten smart over the last year and figured out that I first opened the garage door and then put on my sneakers. Or I could have an engineering degree and just build an Alexa skill, so when I realize after putting on my sneakers that I didn't open up my garage door, I just tell Alexa to open up my garage door. So guess which one I decided to go for. So I ended up building this Alexa skill, obviously using Lambda, using some Node.js, Elastic Beanstalk backend, and obviously connecting it to a home automation system that then eventually could open up my garage door. For those of you who know home automation skills, yes, technically you're not allowed to operate a garage door with a home automation skill. But it's my private skill, so I did it. And most of the time it worked great, but sometimes it didn't. So sometimes I then was standing in front of my garage door and the garage door was closed. That's the point where I realized, okay, I have this really nice, sophisticated, voice-enabled application, but it's great when it works, but it's not so great when it doesn't work, because then I have to get back all the way into the house and open up the garage door or type in the code or anything. And that's when we decided, okay, let's do a talk if you use all these modern technologies and build these new types of applications. Just as the slide says, today's applications are different. So this is not a traditional web-based application with some web front end, some execution logic, some database. No, that is really an application that involves voice, IoT, serverless, so totally different technology stack, and it doesn't have a traditional user interface at all. Still, we want to ensure that they work, and even more importantly, if they don't work, we want to figure out why they're not working. And that's when we started to look at building an application and looking at that application, how it works, and how to diagnose them. The application we are using today here is what we call the UFO application. It's called the UFO application because a UFO is involved. Pretty straightforward. So we built it. It's a voice-enabled IoT application. We also use these things here, an IoT button, and we will also use facial recognition. So a modern user interface that's not based on a traditional web-based input. It's IoT-based input, it's voice-based input, and we even use just the presence of somebody in the room as the input to it. What we're using from a technology stack is Amazon Alexa, the AWS IoT button, the API gateway, Lambda, Elastic Beanstalk, and recognition for the image recognition part of it. What this looks like is this. Actually, I have a clicker. I don't have to walk back there. This is the application architecture of the API gateway, the IoT button, Alexa, some Lambda functions talking to Beanstalk, Beanstalk talking to recognition, Beanstalk talking to the AWS IoT gateway that eventually talks to the UFO over here. So let's see what this application can do. It can turn on a UFO. Isn't that great? That's usually where people applaud and they don't get totally crazy, but wait for it, it's getting better. Because it can do more than that. It can also turn it. And you also already realize that there is some delay. So from a user experience point of view, you might know how long this actually took here. What also works, obviously, I can do the same thing via voice. Alexa, launch UFO.
Welcome to the UFO voice control. You can turn the UFO on and off as well as change its color.
Turn the UFO on. And I'm now turning it off again. And now I need a volunteer from the audience because the last time I was in Vegas, I watched this magic show, and what everybody does in a good magic show, they bring somebody from the audience on stage. And I now need somebody to come to me here on stage, some volunteer. You look like you want to volunteer. Actually, you look like you don't want to volunteer at all. But now there's roughly 350 people in this room. Thinks, yeah, she's going to do that. And a big applause, please. Just, yeah, it's not going to hurt. I'm not going to use any chainsaws and saw into multiple pieces, not going to hurt. It's actually, no, it's not going to hurt, not at all. Just have to walk over here and smile into the camera. And it takes a second. And you see, the UFO turns on again, and as soon as you disappear, the UFO gets sad and will turn off. At least that's the part of the demo. See, it turns off. Thank you, big applause. So what you have seen, we just used a couple of AWS technologies to build an application. Obviously, you could do more interesting things than, well, just turning on and off a UFO. But it should give you an idea that the user interfaces and the types of applications we are building these days use a totally different technology stacks. Still, we want it to work, because if that UFO wouldn't turn on a single time or turn off a single time, you would still say, okay, what's the whole point in there? But user interfaces today are different. And now I'm passing over to you. Now that the live demo work, you can get
exactly
back to the academic part and the slides with the bullet points and everything.
Yeah, thank you. We decided that he does the fancy part and I do the theory slides. But bear with me. After really we are through that, you are able to use actually a lot of AWS, what's already there, to create your own monitoring solution with board things what AWS gives you. So there are different types of monitoring, of course. And I don't know, who monitors their current application stack? Still not everyone. Who monitors to find out about system health, after all? Who monitors to understand dependencies between devices or application services? Okay, Lessa. And who monitors to tune applications? Okay, I see. And who monitors to improve or to see how the user experience is of applications? Still a few, so it gets fewer and fewer. And interestingly, that would be our priority here. So first of all, I would say good user experience is important. I mean, we can look at metrics all the time, but in the end, it's about how our users feel. And maybe this does not so much match this whole IoT idea, because user experience in the browser, JavaScript involved, etc., of course, important, but what is the user experience of such a button, right? But especially with IoT applications, we are conditioned to expect way better user experience than even in the browser, because when you are in a browser application or website, you click a link, you expect that it takes some time. And then when you click on some button and you're kind of conditioned by light switches, you expect that it reacts like instantly. Like here at our hotels, look at the people that try to close the door of the elevator. It's never one button press, right? It's always 10 until the feedback comes and the door closes. So I'd say user experience for IoT, very important. Of course, still we want to learn about application health and also understand the execution logic. So how requests traverse this whole stack, because especially for IoT applications, this is extremely complicated because they are by definition distributed and complex. And maybe we also want to tune our systems, of course. We need to collect metrics to know how the system is now, to understand if changes that we make are changing things to the better or worse. And which artifacts of monitoring can we collect of our systems? First of all, we have time series data. This is continuous data. It's a value attached to some time. Makes sense. Then we have events. Event is a discrete kind of data. It's a 1 or 0. It's a on or off. It's something that happens or not. We have logs. We all know them. They are everything. They are kind of semi-structured. You can theoretically put everything into that, but we will come to that in a little bit. And then we have traces. This is tree-like data, because there we really have to know how different artifacts relate to each other, because what was before, what comes after, that's traces. And using traces, we can also derive environmental dependencies by simply adding, for instance, the application it runs on to these traces, or the zone, like the AWS availability zone to a trace. Then we know, okay, this runs in this environment. So we annotate this information with environmental dependencies. And of course, we may also want to know how our code execution is doing. This is already, again, quite complex, because we have to time in a way how our code executes, and also add this to the traces. So let's start with the metrics. What could we do with metrics after all? So we could, for instance, find out how one resource, like one instance, is doing by collecting CPU, memory, network information. But we could also want to know how applications are communicating, and there we mostly want to know the response time or error rates, etc. Or we want to know more about an environment, and for that we would collect instance counts, for instance, throttles, etc. But we see here already there are a lot of traces, metrics that we could take. So most probably we want to focus on the more important ones. And Amazon CloudWatch actually gives you all this information, because most AWS services already report to Amazon CloudWatch, and you can define custom metrics, you can define alerts, and you also can access logs there. Here we have a dashboard that Alice wants to describe.
Yeah, so this is, back to Daniel's point, it doesn't really help you to create all the metrics that you could get. What we recommend for all of you, who's using CloudWatch metrics already of you? Okay, some. Actually, all of you should be using them, because they tell you how your system's behaving. This is a very simple one. Again, you could have 50 or 60 metrics per application tier, per service that you're running, but it just gets a lot. What we found very useful for people to get started with is just focus on 3 main metrics, which in this case are my invocations, the number of requests, the number of invocations, response times, and then environmental health, meaning errors. So just by knowing the load, response time, and errors, you already have a good understanding of your environment. It's just looking at like basic health metrics also of your body. Like if your temperature is right, if you're feeling okay, that's fine. So these are the ones that you should start. And the application that you've seen before, like we have the same for web, voice, and the IoT button piece. If you don't want to build a lot of dashboards, this is the minimum dashboard that you should really look into, because it gives you a basic understanding, is my system doing fine, or isn't the system doing fine, and what's the load like compared to a different time frame.
But hey, what about logs? So who uses logs to monitor log data to, some. So actually logs were invented to log out some very specific information like error conditions, stack traces, etc. Security breaches, someone is hammering against your endpoint. We today saw that our UFO, for instance, is accessed from a variety of other, I don't know, systems, because someone is mixing up their IP address and then the requests come into us. Or you also want to understand global problems like some crash. This is what logs are for. I would say using logs to write metrics to it does not make so much sense. Why does it not make so much sense? Because when you collect data, and you write it to a log file, then you need another process to get this data out of this log file, split it again, and write it into some better form, into some database or whatever that can digest time series better. So why don't we do this directly? Why don't we use logs? Do we use logs as indirection here? But this happens quite frequently. So I really advise to not abuse log files for that. Of course, logs, you know them, hopefully CloudWatch logs. Of course, anybody that ever had to debug, for instance, a Lambda function knows or hates them because you use them to find out what the actual problem was. So what do we do with trace data and how can we collect it? So you get trace data when you really trace every transaction running through your application. This means you have to carry through some ID of this transaction ideally from the user device down to the database. And by doing so, you find out how an individual application can interact, and also you may better understand specific problems, because of course, if there is some slow API, some slow endpoint, a trace can tell you exactly where this is. With metrics alone, you just know something is slower, users are frustrated, but no idea where this is coming from. So tracing gives you also timing information so on the edges between two nodes. This helps you, of course, understanding problems in distributed services, and also gives you a way to enable high-level production monitoring. For instance, you could attach some ID to every user transaction and store all traces, and when the user then calls in, you can ask the user for the ID, and then you know exactly what happened when the user had this session. And with that, you really have valuable and valuable information that you then can pass on to development, for instance. So very important. And AWS X-Ray gives you all of that. Anyone uses it already? Yeah, not really much, really.
I think after we show them what X-Ray can do.
Sure. Really, it gives you a lot, and it's quite cool. You will see it in a second. So this really gives you, within AWS, this really gives you already traces, it gives you service maps to really understand what's going on in your system, and it also allows you to export this data or export this to other monitoring systems and they can digest this data and use this data to also create their traces there. So here, for instance, we have an X-ray trace. It's a little bit small.
Yeah, we can go into the live view. We can show it live.
Yeah, do it live.
Yeah. Okay, so for those of you who are not familiar with X-Ray, or not using it, we actually used X-Ray a lot for our development purposes here. Let me just Okay, I just got logged out. So you see, this is really a live demo because
Totally, it's not video or
it's
something.
not a video because why would somebody record this on video? Anyway, so yeah, it's just part of your AWS services. And what you can see in here is a list of traces. This API UFO find faces call that you see in here was exactly when we first on stage were doing the facial recognition piece. If we go further back in time, because this only shows the last 5 minutes, you see that there's a lot more traces. And to Daniel's point, what we learned today, let's look into 6 hours. Somebody is running a billing service over our UFO demo, as you can see maybe up here. I might make it big. So it also helps you to maybe understand who's using your system. So we are definitely not providing this content here. So this is a live AWS environment. Sometimes people mix up IP addresses. Yeah, what you then can see, let's pick one example here. Oops, unfold here, yeah. This was what the X-ray trace, in this case, looks like for, in this case, this is the facial recognition piece. We see that the UFO dev dynatracelabs.com was the call to that website. That made itself a call to recognition. And we can see all the details about this call to recognition. It returned a 200 OK in this case. And what it did as well, it via one interaction, so it's actually calling itself. It also calls the IoT data request and also sending off a request asynchronously that you can see down here to the AWS IoT services that then talk to the UFO and turn on the UFO.
And for everything, you have this timing data, so it really tells you what's going on and how long it takes, and you find through that you can easily find bottlenecks. So it's.
If you think you don't want to work with this data visually, which is, by the way, really nice if you build a rather complex system to just visualize it that way and understand it, and say, but you want to automatically process it, you get the same in a very nice JSON format that you can access as well and then do some post-processing with this type of data as well. So who's now going to try X-Ray and might think it might be helpful, who hasn't used it before? OK, good.
Well,
not fully convinced yet, I think. Yeah, well, we're getting there. Now, seriously, especially if you build applications that are more complex, it really helps. And you also find information that you would not see in your code, by the way. What you can see in here for the, this one is really small. Yes, right. It's the IoT button. What you see in here is also information about dwell time when you start a Lambda function, so the time it takes to start up that function. Or retry attempts in your code. Like if we will see later on when we press the button and it does not work because something's broken, there's a number of retries happening in your Lambda functions that are linked to your IoT devices. Who know that there's retries involved? And it does 2 to 3 attempts for invocations. It actually does, and X-Ray will show you exactly this data. So super helpful, as Daniel mentioned, to understand execution logic and as well how your individual systems work together, including timing.
Using this trace, you can call this frustrated user that just pressed your button 20 times and ask what's wrong with him or her. So maybe we can impress with the dependency graphs.
Maybe, yeah.
So dependency graphs now use this tracing data and add structural information, topology information to it to know where this trace is running on. We talked about that before. And this is what you get then also through X-Ray. So as you see here, this dependency graph now gives you a full overview of your system, how those different tiers are connecting to each other, timing information, so which also the clients that are accessing this infrastructure. And that's, again, very interesting because maybe you don't want a client to access this one service directly. Who knows that? So this really tells you a lot about also problems in your architecture. Maybe something is wrong. Maybe you're using an API directly from the client that you don't want to use. That is all what tracing data can add to that. Do you want to show something?
Yeah, we can show it actually. We can show it live. Now I just broke something. So this is, you remember that before I showed it in PowerPoint, and this is what our application looks like. This is the application that you had looked at before. Here you can see the IoT button. the IoT button calling the IoT Lambda stack, calling the Lambda function, calling the UFO backend, calling recognition, and also calling IoT data in this case. If we go back a bit further, we would even see more of them appearing, like the Lambda function that was executing for Alexa. So here you have the Lambda stack for Alexa, again, calling that Lambda function, calling the UFO. And what you could also do in here, you could obviously also then look at, okay, where do errors occur? You could filter those. You could add on top, you could request, like I only want to see transactions that failed, get access to this information. So this really shows you what your application looks like. And again, this is built on trace data, and that's how you should create dependency maps. So if you create your dependency maps just by bringing 10 people in your organization together to figure out how they think the application works, this is maybe a much better way because this shows you the application, how it's really built in a production environment. Yeah? We come to the code instrumentation a bit later, yeah. But the answer is, yeah, there is code instrumentation involved. We'll show the example for Node.js in a couple of minutes, yeah.
Okay. Code level data. That's, I would say, the last piece here. How can we use that? Of course, if you, and back to code instrumentation here, to this question, of course, if you are able to instrument your code in a way, or it's maybe monkey patched by a tool, and you can time your function calls, you can also add this to traces, and then you have, I would say, if a trace is one tree leaf, then you can add subtrees to that really represent your code and tell you, oh, this function was slow, I'm losing time in this function. So this is what code level data gives you on top of all of that. So let's configure some live monitoring. I mean, Alice is already eager to do that. So we want to know, what are my users doing? Is the application actually working? And is the infrastructure even healthy? And also, we want to define events here and alerts about, is my response time too high? Is my error rate too high? And also, is my infrastructure healthy after all?
Yeah, so for those of you who have, we have seen a couple of people who haven't used CloudWatch before. If you jump into CloudWatch, and you have internet, you have a menu item here that says dashboards, and I already built a dashboard that you have seen before. So what you can do in here, you can add your custom widgets, the ones that you've seen before. That's the same dashboard that you saw before, now with the data that we put in there. And overall, it's pretty straightforward. You just add a widget in here. You just pick what you want it to be, a line, a stacked area, a number, a text. Let's just pick a line area here. And then you pick the service that you're interested in. Let's take, in our case, recognition, and say operation metrics, and we care about the response time for our index phases. What index phases does, for those of you who haven't used recognition, so when we did that facial recognition that turned on the UFO over here, I used the index phases method of recognition, streamed in the live image, and asked it to find all faces that it can find on that image. And that's the recognition call that you see in here. And I might now add this. And now I'm getting the response times in here for my recognition call, which in this case is about 1 second. This is already very helpful information, because in case this takes some time to turn on, you would know where you're actually losing the time. Is it because of the images you pass into recognition might be of a bad quality, because of bad lighting, so the runner might pre-optimize them to tune recognition information in here, or other things. And obviously, we have the metrics that I've shown you before. The nice thing is you can just build those dashboards, you can create those widgets, and you have them available in CloudWatch, and then you can also easily share links to those CloudWatch dashboards. And all of you, for your core application and core services, should have those dashboards. Just, as said, put all the widgets together and define whatever you need to do. Yeah. Okay, next is alerts. I'm not showing the alerts live because it doesn't really...
Yeah, I give you that.
Okay. Okay, so as Daniel mentioned, we are actually more interested in events when we talk about metrics than the actual metrics in most cases. So it's great to have a lot of metrics, but what we really care about, did the metric change in a way that we are not really happy about it? Which usually means it gets worse. Response time getting higher, error rate increasing, or maybe a user's using our service less. How can you do this in CloudWatch? So first of all, you pick the metric that you're interested in, like response time, for example. And in the next step, you have to define a threshold for this metric. What comes in pretty neatly is this alarm preview. But what you have to define in here, you have to figure out what this threshold is supposed to be for the metric. This is actually mostly used for SLA type of monitoring because you have to set a predefined threshold for your services. We will come to anomaly detection a bit later, what anomaly detection does for you. So here you set up this threshold, and in the next step you define the action, which usually is sending an email, sending a text, whatever you want it to do. So just defining your notifications, and you're all set. Now we're coming to instrumentation with X-Ray. So back to your question from before, do you need to instrument your code? The answer is, like for every good technical question, it depends. It depends why. So for example, for Lambda, if you have a Node.js Lambda function or an Elastic Beanstalk environment, you can't just switch it on in the user in the UI. They're not super consistent yet. Some of them are already called Enable X-Ray. Others are called Enable Live Tracing. But they're consolidating these right now. I've recently seen the names changes in some of the components. So for all of the inbound calls, you don't have to instrument your code. But if you're using some frameworks inside that do outbound calls, and to see those outbound calls, you will have to instrument your code. So how do you do this? Instrumentation with X-Ray will enable you to see those traces that you have seen before, the traces and the maps. You have to start the X-Ray daemon on your environment. For an environment like a Beanstalk environment or Lambda, there's just a checkbox in the UI. But technically, you can run it on pretty much every environment that you're using by just installing either the daemon or making it part of your deployment. Instrumenting the application to send tracing data and adjust your security policies to enable X-ray tracing. I'll show it in a minute. You also have to set your security policies appropriately because otherwise your Lambda function might not be allowed to write X-ray tracing data. I realized last week that and these slides, obviously we had to hand them in a bit earlier. This just changed recently for Lambda. So in the past, for Lambda, when you enabled the tracing, you had to manually go to your the roles used for Lambda and allow them to do X-ray tracing, which was the #1 reason, if you forgot about this, why you didn't see any data. What they just recently did, if you now enable the tracing piece, this is an example of ELB, the same, it looks pretty much the same on Lambda. Now there comes a warning in Lambda that shows you that they're adding an additional right to your IAM role that's using it. So that became more convenient than it used to be. But still, you have to enable X-ray. So the left side is what it looks like in Beanstalk. The right-hand side is what it looks like on a Lambda environment. Again, the roles, you had to define those roles. I think for Beanstalk, you still have to do it, and for other services, you might have to do it as well. This is the convenient way to doing it. What you really need is you need the X-ray write-only access in this case, because you need the services, obviously, to only write X-ray data. You don't need your services to read the data again. This is an example of adjusting your source code for Node.js. So we would see some of the traces inside the code, but not all of them. You're using, in this case, the X-Ray library, which you have to make part of your application. So we're requiring the X-Ray SDK in this case. Then we want to capture all of the outgoing HTTP calls. What we're more or less doing, we're wrapping the require with this X-Ray capture HTTPS global. And then we have to wrap the AWS SDK as well to get all the AWS SDK calls. If you remember before in the traces, what you could see is that there were the calls to recognition, to IoT as part of the service map. And they're shown in there. The reason why this was the case is because the SDK was instrumented here as well. And the lower portion here is if you're using Node.js, you most likely use a framework like Express. This is what you would have to add to Express in this case. You have to tell the app to use the X-Ray open segment call. In our case, it's the UFO server. Enable some dynamic naming, in our case, on the Dynatrace Labs domain. That's the UFO. And at the very end of your Express-specific code, you then have to use AWS X-Ray Express closed segment. So a segment is one of these trace parts that you have seen in those traces, and that's the way how you have to touch your code. So you have to link an additional library and touch your code to get all of those details. By just enabling them, you would see the inbound calls only.
Let's break
That's
something.
my favorite part of the presentation. So let's now break the application and see what we see. So what we're going to do right now, I'm not making the UFO not work anymore. So one of the really nice things of what we're doing is there is a switch to make the application not work.
As everyone has a switch to break the application, right?
Yeah,
That's
I mean,
what
everybody
usually
builds this in.
happens.
And the easiest way to break the application quickly is to just open the face detection piece again, turning on the camera, and now we'll see it's not going to work. Recognizes, but doesn't turn on. Like my garage door. Same here, if I press that button, nothing's happening. So, what do we do now? Obviously, and keep in mind if this is a rather complex application, starting with logs here might be pretty tough. Because if you really have a Lambda application that consists of 200 Lambda functions, which Lambda function would you start with? So let's look at what X-Ray is telling us. Yes? Oh, something's broken. Well, we already knew that, right? So what you can do when you look at those X-ray traces, you can define you're interested in those having faults and those having errors, and just view those traces. In our case, it picked the find faces one, which isn't working right now. And now we see that this call here to the backend failed. The recognition call went fine, but the backend call to the UFO failed. And if I would look at all of the other traces, I would realize that this is the reason why it's not working. Okay, now we have looked at the trace data, and now we have to find out what's really going on here. So I'm going over to my Lambda function, and I have to pick that Lambda function, so I have to remember the Lambda function I was looking at before. Okay. In this case, this was the... No, sorry, this wasn't Lambda, it was the LB environment.
There already see you can actually, this workflow can still be improved also on the AWS side, so it's not so easy to find the stuff and then to drill into the problems, because not everything is connected here.
And we'll come to, okay, so we don't see the errors here yet coming in. Configuration. I could have jumped to the logs directly, but jump to logs. And now we would have to have a couple of logs, but I know that it's the Node.js process, because it could be the Node.js process or Nginx. In this case, it's the Node.js process. We jump into the logs. And what we see here, the server is not amused right now. Server is not sending back a response. Okay, so we used the tracing piece, and then we jumped over to ELB. We realized that the server is not amused right now. Let's re-amuse the server. Let's unbreak it.
That is also in your application.
That's every application has this button, fix me, right? So as you can see, usually trace data and understanding how your environment works is a good start, and then you might dive deeper into logs and other data and use the different services as you need them. Yeah, that was the piece that was broken.
Okay, but you already saw, I mean, this was a lot to do, right? Finding out about the error, your boss sits next to you and says, fix this error because we are losing money here. So it took you a little bit of time to fix all of that. So what can we do with all this monitoring data? So all monitoring data that we have here from AWS, we can actually also use it by, or let it ingest by other tools, or use it then to do more sophisticated things with it. For instance, for operations, we can use it to alert on application issues or resolve also issues. And we can optimize applications because if we understand the architecture, we can make our architectural decisions better. For instance, you have some service calling another service in a total different availability zone. You most probably want to change that, and this is what you see through this information. And of course, as I said before, also optimizing is dependent on metrics. But what we actually care about is actually events. It's about change. It's about, is something deriving from maybe a normal state? And for that, we need something called anomaly detection. And there are two ways to do that, or two kinds of data we have here. First of all, we have anomaly based on historic values. What does this mean? If an application did run on the same load last week and it had maybe this CPU saturation, and now it has doubled the CPU saturation this week under the same load of users, most probably something is broken here. So that's historic data. Or we can, of course, also define anomalies based on thresholds, because, I don't know, 90% CPU usage is most of the time not a good sign. That still tells us what is wrong, but not the cause of a problem. And again, and also, anomaly detection always is just based on metrics. It's just how do these metrics look, and are they valid? And the flow to find out anomalies is all the time that. So you have some historic data, and you feed it into your model, and you say, okay, that's my normal. Then you have new data in, and you intersect that with the normal model. And from the normal model, you derive a hypothesis. This means you want to know, okay, is this still normal, or do we really have a problem here? And from this hypothesis, you can derive also a judgment that to know, is there now something wrong or not? Is this a problem or not? Is this an anomaly? And if there is an anomaly, you can start alerting.
Yeah, maybe for anomaly detection it was pretty high level, so we could do a full 60-minute talk just about how anomaly detection works. Just keep in mind, it's complicated, but it works.
Of course, we also want to know how these changes, and there comes the exciting part about tracing, are actually related to each other. So for instance, there are temporal dependencies. I mean, if, for instance, a service goes slow and you have, I don't know, the CPU saturation 2 hours later, this is most probably not related, but in the other direction, most probably there is a relation. And also, of course, causal dependencies. Event A can be caused by event B. And here, so if we now use the metrics that we gathered before and combine that with the tracing data we have, we can actually create a graph of our infrastructure and our system. We found out how different services depend on each other on every layer. This means also on process layer, also on network layer, also on application layer. And now we detect some service slowdown. So we see there is something slowing down, but still no problem because, I don't know, users are not affected. What should we do? Suddenly, also dependent services, and you see that here on the graphs, these are services that have a directed edge towards this service that has the slowdown, are also slowing down, of course. And suddenly, here, the last dot, this is the user request. Suddenly, users are affected as well. Now your boss calls you, and we really have a problem. So to analyze that, we can now look into which services are part of this whole problem. So we follow the graph model and find out, okay, which edges go towards the problem that we saw. Then we can factor out already non-relevant services. This means everything that is not part of this problem, we can factor out of this problem. And then we can follow the problem, the errors. This means basically you follow the graph here, and in the end, this will bring you to the root cause of this whole problem. So this is how a root cause analysis works. And for that, you don't basically have to define anything. So this works with the model works out of the box. So without the hassle of drilling into stuff or looking around. So this is an easy way to find the problem. But how does this work? So which tool does offer that? So this would be...
we brought one today, I think.
This would be an example, a live example of a real example of a product that offers that, Dynatrace, and Alice will now show how this looks for real, again, with data from AWS.
Yeah, so you've seen that you can do a lot with the means within what AWS provides. You have X-Ray data, you have the CloudWatch data, you have all of this data. But what you want to do eventually, you want to build all this analytics on top of that data. So what do you want more than just what you have with AWS? You want to have the correlation across your monitoring data and this AI-based analytics, so that dependencies that Daniel talked about is something you want to put into an AI model, understanding that if a CPU is saturated and a service is slow, that this is related to each other. Pretty obvious to us humans, but not so obvious if you just look at large amounts of monitoring data. If you then have this AI-based analysis, this root cause analysis, you've seen it in the example before, you can also connect this to other systems, like there is the AWS Lambda Health project, which is a number of open source tests that you can trigger if something goes wrong in your environment. So assume you figure out your root cause is that your CPUs across all of your ELBs are totally used up. So what do? You create increase the size of your increase the size of your environment. And obviously understand user interactions and flows. So everything we've seen so far really starts at the Lambda function, but we could not attribute it to an individual user. So what I'd like to show you right now, what that Lambda environment really looks like, and this will also be an example that serverless is not that serverless. Also, as Andy Chassie presented in the keynote today, it just means, okay, so what we do, we combine like all the data that you have seen before for this example that you have seen into a model, and I can pick here my backend system and discover the entire stack. So before we have just seen the trace in one direction, now I can go down to the process level, all the way down, figuring out in which availability zones it runs, and visualize my entire environment, what it looks like. So I'm more or less ingesting all the data that I have in CloudWatch, all of these APIs, and putting it into a single visualization, showing me my entire system on different levels. So whether it's the availability zone level, the processes that I'm running, or also the services that I'm interested in. And in this case, this is actually quite interesting because this shows for a Lambda function, I must make it a bit larger, where it's actually running. So this is a Node.js Lambda function that's running on this machine. So you see by adding, in this case, the Dynatrace agent on top, I can discover even my entire Lambda environment and see all this information there. Okay, so this is already helpful information that I can see here, more or less putting all the information I can get out of AWS in context. What I can do next is monitoring it from a user perspective. So if that button did not work, and assume this is a dashboard and you really can buy something really expensive for it, or you could just order something on your room. Like you're in the Venetian, you go to the party Thursday night, and this can just order you a bottle of water, and it doesn't work. You might be really not amused about this. So what we can do here, we can jump right into, where's my applications here? Into what we refer to as real user monitoring. I have an application that they call UFO, and I see everything that I have done in this application. So just as it was, just if it was a regular web application, What I can see in here, I can see all my double clicks, my single clicks. The single clicks turn it off. The double clicks turn it on. I have the launch session command. That was the Alexa piece. If you remember before what I did, when I said, OK, launch UFO, that's what you saw there. And turning the UFO on and turning the UFO off. So you can see all those user actions. And even more than that, I can also relate these users. I can relate it to an individual user. So looking at the user action, I can see what I did over time. So in the background, I was just pressing those buttons. Like in this case, I can see that I was double-clicking this button here. But I see my entire history of my entire interactions I had with my application here. In this case, the longer one is usually a voice interaction, as you can see. This was the launch session and turned the UFO on. So if a certain user is having a problem, you can ingest this data and also follow exactly what this user did. You can then even take it further if you look at the data. And let's look at the Lambda function we were using here, which is currently having a failure rate increase, which we were expecting, right? And visualize also the service flow that you have seen before, and even diving deeper into here. So it's not really built for this resolution as well. Here we go. So the same information I can get here, and we were talking about code level analytics. I can go into now an individual transaction that failed, because there's also the Dynatrace agent in here as well. So what I can do in this case, I can now really go down and look at code level details that are added by Dynatrace. So with AWS X-Ray, what we already got all of these dependencies, whether they worked or did not work. And now for my Lambda functions, I can see the actual code that was executed. And to your question for this, you don't need to modify your source code. You just would have to change the handler that you're using as part of your Lambda function. But again, I don't want to do this manually, so what I can do as well, what Daniel showed us, we can also see the dependency where our Lambda function was, where it analyzed the dependency in our Lambda function and did the problem analysis for us and automatically analyzed the dependencies, also telling us that right now the function is already back to normal. And once I drill in here, and look at, there we go. OK, that's already shut down right now. I could also then go down deeper into the logs. So this dependency analysis that you've seen before, you get this more or less all out of the box, and you could jump directly to the logs and directly to the code level data. And as always, there is one more thing. Sometimes I might just be sitting in my car, not in front of my computer. I also want to do it voice-based. So one of the reasons why we decided to go for monitoring of Alexa skills, because we had our own Alexa skill as Dynatrace. And we thought, well, one of the main reasons being we wanted to just ask it a question about our environment. And we created our virtual bot, which we call Davis, which I'll just briefly show you. Alexa, launch Davis.
What can I do for you?
Open Dynatrace.
Here is your dashboard. It seems that you don't have any open problems. Is there anything else I can help you with?
What happened since yesterday morning?
She's thinking.
Yesterday morning, 12 problems occurred. The most affected application was VMware.easytravel.com, which was affected by one issue. The largest concentration of problems was around yesterday at 12 a.m. Would you like to hear a listing of these issues?
Yes, please. So what you can see, you can do the same interaction with all the monitoring data that we did before. I'm not just using Alexa to do it and guide me through this entire process. Unfortunately, 4G is not the fastest in here, nor is the Wi-Fi. But
First, there was a memory saturation on OpenStack controller node. Second, There was a degraded service response time on .NET Backend Easy Travel X64 on port 9010 with a detected root cause. Finally, there was a degradation in user action.
I think you get the idea. By the way, we have a booth over here at the ARIA and also over at the Venetian. So if you really want to give it a try, you can go there as well and talk to the team. So the idea is there's a lot that you can add on top of the AWS. So AWS data is great. You get a lot out of AWS from monitoring data, but you can put a lot of analytics on top, and you can really get it to a level where more or less you have a virtual DevOps team member that can do all this. You can automate all this analysis. You can even, which I didn't show today, trigger a remediation task by just saying roll back the change that we made in our application. You have just seen that demo right now. And if you go, by the way, to the AWS Marketplace, you can give Dynatrace a try. There's also a free tier, like 1,500 hours. You can just add it to your application. You can try pretty much everything you've seen today. And for those who really like those UFOs and who want to take a bit of a walk, we are printing some of those over at the Venetian. So if you stop by the Dynatrace booth at the Venetian, you can also grab one of those UFOs. And now we have roughly 4 minutes left, and I'd like to open it up for questions. Yes, sir?
You guys talked about logs and tracing, but like, I'm sure I'm not alone in that we have a huge amount of like single data metrics, you know, histograms, counts, timing requests for single things, you know. Where do you guys see that sort of thing fitting in, tracing and all the other stuff that's really catching on?
So the question was, where do single point metrics filled in, like histograms, single data points that you're collecting all across your application? And there I really like to use this analogy of a doctor. So when you go to a doctor, there's always a couple of metrics, how whether your system is healthy or not healthy. And the reason why you have those metrics most likely is because you once had a problem where exactly this was the reason. The point is you just keep adding metrics and metrics and metrics and metrics and metrics. So you have to have some, I'd call it like metrics hygiene. Think, okay, which are the ones that really help me to best diagnose those problems, or which are generally available, which people actually understand in all across my company. So there's two ways to deal with them. Obviously, if you put them into like an anomaly detection algorithm, like you could do with Dynatrace as well, people wouldn't need to understand them in detail. You might know them, you know, okay, if like that curve of that matrix behaves like this, it's going to cause me a problem in 2 or 3 hours from now. So this is very much expertise knowledge. That's like if you go to your local doctor, he might just take your temperature and do a couple of smaller tests. Once you go to a specialist, they might look at these additional metrics. So we see them as being relevant for the experts in a certain part of the application and keeping them there. But for whoever is responsible for the overall application, they might not necessarily care that much about them. So putting them in the right context is really helpful, but showing them to everybody necessarily is not. And we really recommend also then really putting some anomaly detection on top and also documenting them. By the way, documentation is a good way for metrics hygiene, because once you force somebody to write a documentation about what this metrics means and how it behaves, it takes them at least an hour of their time. If it's really important, they do it. And if they don't do it, it might not be that important. So but it sometimes helps to really reiterate over those metrics whether you still need them or not, because we have seen situations where people end up with 200 metrics, and then you ask them, why is this metric there? I don't know, Greg put it on there. Okay, so Greg's not here. So keep it still, try to keep them to a minimum, but understand why they're there. But having maybe a quarterly review of your metrics, whether you still need them or whether they still make sense, is definitely a good practice. Other questions?
Just curious what impact from your experience you've seen in terms of code instrumentation.
Question was about, now we're getting really deep into physics, Heisenberg's uncertainty. You change what you observe. Yes, that's true. But modern code level instrumentation technologies, you should look at what you're using. And like the technology we're using, we put a lot of effort into keeping the overhead minimal. So usually this is more or less in the microsecond to millisecond range for what you're modifying. And by the way, good monitoring and tracing tools exactly tell you the overhead they have. If you get any tracing inside your application and it doesn't tell you what's the overhead that it adds, usually it's you should look into whether this is really the right tool to do it. When you look at overheads, also a recommendation, really look at absolute response time overhead, because relative overhead sometimes is a weird metric. A lot of people will take it 3 to 5%. It really depends on what type of transaction you're looking at. If you have a Lambda function that's running in the 1 or 2 millisecond range, it's different than if you have a Lambda function that serves a front-end user response with like 200, 300 milliseconds. So 15 milliseconds wouldn't play that much of a role there. But overall, modern tracing is not that it massively slows down your application. And the benefit you get is definitely worth it. But we rarely hear really complaints that it slows down the system significantly. If you're really uncertain because you have some time-critical things you're working on, you can still test the before and after of the instrumentation. But today, instrumentation technologies, they have been around for almost 20 years, so people know what they're doing when they're building it. Other questions? Yeah, go ahead.
Did I understand that this code instrumentation you showed earlier is just out of the box, Amazon, but what we saw, we sort of drilled into Lambda,
So the way the instrumentation works, so I showed out-of-the-box AWS instrumentation. Some of it comes out of the box. So all the inbound calls, they come out of the box. For the outbound ones, you would have to do code instrumentation. The way we built our instrumentation that you've seen here is it automates the code automatically. So you just add a library to your Lambda deployment, which you can do with code pipeline. Just modify the way you call your handler, and then you're done and you're not touching your code. So you don't have to touch your code to get these code level details that you've seen before.
Because after all, such a Lambda function, Node for instance, it's still a Node application running in some application server that is called. So you can basically then, as soon as the agent is in, you can get metrics out of it, every metrics you would expect from an application. That's quite cool. I think time is off.
I think they're kicking us out right now.
Thank you.
If you still have questions, ask us here.